Assalamualaikum warahmatullahi wabarakatuh. Today I'm going to continue my lecture on buoyancy and stability. So first I explain on buoyancy. So what is force of buoyancy? So force of buoyancy is the vertical forces exerted by the fluid on immersed body. Or in the easy way we can say that force of buoyancy is the force that lift up the object. Okay, let's say we have a object in a water. So this is the object. It's a cuboid, okay, floating in the water. So here we only have two forces. Originally have two forces. Only weight of the object downwards and force of buoyancy upwards. So how to draw the two forces? So we know that W acts at the center of the object, center of the gravity of the object. So from the center of the gravity we draw the line downwards. So force of buoyancy. So where is the force of buoyancy X? Okay, force of buoyancy act at the center of buoyancy. Okay, remember last two class we have learned on hydrostatic force Fr. When the Fr act at the CP, center of pressure. So now center of buoyancy act at the CB, center of buoyancy. So what is the center of buoyancy? The point which buoyancy force is acting. So that's why I draw the FB from the center of buoyancy. So where is the force of buoyancy? Where is the center of buoyancy? Okay, center of buoyancy is the centroid of the displaced volume of the fluid. Okay, like this example, if we have cuboid, so means this is the volume displaced in the water. Okay, volume displaced mean the immersed part of the object. So center of the immersed part, this is the cross section of the immersed part. So the CB will be at the centroid, center. So means if I put H as the depth of immersion, means CB located at half of the H. So now, what is the procedure to solve the buoyancy problems? There are three procedures you must follow. Means if you read the problems is about buoyancy, so remember the three steps. So number one is draw free body diagram. At this step, you must list out forces in vertical directions. Okay, list all forces in vertical direction. Like these examples, we only have two forces, W downwards and force of buoyancy upwards. Where is the Fr that we learned last week? So remember, Fr is if we draw the Fr is the horizontal force to the object. So in buoyancy, we only consider forces in vertical direction. So only two forces, force of buoyancy and W. Okay, step number two, do summation force in vertical direction and write the equation equal to 0. So we only have force of buoyancy upward positive FB minus W equal to 0. Okay, step number three, solve for the required by applying buoyancy principle. So in this subtopic, you must remember this equation. FB, so remember FB is about fluid. So if FB is about fluid, so we need to use the density of the fluid. Let's say the object is immersed in the water, so we use the density of water times G time volume display. Volume displaced. What is the volume displaced? This is the volume displaced, means the immersed volume. So this is a mathematical problem. Is if you want to calculate what is the volume of this displaced. If a cylinder, so use the pi d square over 4 times height. If the cuboid, so length times width times height. Okay, it's a mathematical problems. So you have to remember W, or either you use W equal to mg if the mass of the object is given in the question. If not, then we use the rho gv. So remember, W is about object, so we must use the density of the object and volume of the object. So what is the volume of the object? The volume of the object is all of the object dimension, length time width time length time height of the object, not hash immersion. So I put here hash is the depth of immersions. So if the problem doesn't give you the depth of immersion as a hash, so you can put any unknown, r, s, t, u, a, b, c, doesn't matter. So normally we put as a hash. Okay, remember 3 steps to solve the buoyancy principle. Number 1, draw free body diagram, list all forces in vertical directions, do summation force in vertical direction equal to 0. By using the equation, solve the problem. Either your problems need you to calculate the depth of immersion or volume displaced. So now take a look at this example. You can refer Q232 in our tutorial books. So we have an object, it's a wooden block, given specific weight is 6.4 kilonewton per meter cube and is immersed in the water. Okay, so if we look at here, so the wooden block is the density is about maybe divided by 9.8 watt, maybe around 700 and something. So water is 1000. Logically, if the lighter object in the water, so the object will be floating like this lah. If the object is dense compared to the water, so supposedly the object will be fully submerged. Okay, we can check first, either the object is floating or fully submerged. Okay, so now water, we know the density is 1000, the specific weight is about the specific weight is about 9000, something like that. So the water is more dense compared to the wooden block, so the wooden block will floating. So the problem is find the volume of this place and depth of immersions. Okay, what is the volume of this place? So this is volume displays. If you get the problems on buoyancy and stability, so first maybe you can try to sketch where is the volume of this place, so that you know how to calculate the depth of immersion. So now in the question didn't give you the hash, so now I put hash here as a depth of immersion. You can put any unknown, but normally we put as a hash. Okay, so if you know it's a buoyancy problem, so you know you have 3 steps to follow. So number 1, draw free body diagram. So draw free body diagram. So in this question we only have 2 forces, force of buoyancy and weight downwards. Okay, so only 2 forces, FB and W. So draw the free body diagram. Step number 2, summation force in vertical direction equal to 0. So FB positive outward minus W equal to 0. So now substitution the FB equal to raw fluid. Remember, FB equal to raw fluid, G volume displaced. So either you want to calculate FB at the outside first, calculate the W, and then you plug in the equation, doesn't matter. Or you want directly put the equation inside the formula inside the equation, also okay. Okay, so we know FB equal to, so if you want to calculate here, we can write FB equal to rho of water. Remember, FB is about fluid, G volume displaced. So W equal to rho object G, volume object. Remember, W is about object, so we have to use the properties of the object. Okay, so what is the volume of the object? So volume of the object is the volume of the wooden block. So equal to length times width times height. Length 3 meter, width 1.25, height 0.75. So we get the V object 2.812. Okay, because the question asking to calculate volume display, so you remain as a volume displays. So after you plug in the figure in the equation, so we get V volume displays in 1.835, means the shaded volume is 1.835 meter cube. Okay, question number 2 asks calculate depth of immersion, means if I put hash here means we want to calculate the hash. So we know the volume of the shaded area is length times width times height. 3 meter times 1.25 times h. So we already get the volume displaced by using the buoyancy principle is 1.835 meter cube. So apply it in the question, so we get h equal to 0.485, means the depth of the immersions of the wooden block equal to 0.489 meter. So if you want to use this principle dekat rumah, try to calculate what is the volume of the what is the depth of immersions of the something object that floating in your house. Try to put in your mom's sink or whatever. You can try by using the buoyancy principle. Okay, thank you.